All right, so we are in for lesson 10, still about the planes, angle between two planes, and something very simple. Now, anything to do with angles in vectors, we go about the dotting. So therefore, recall. Now, in a plane, what do you expect? A normal vector is what we respect there. Recall, angle between two planes, you say any one, this is normal vector for plane 1, dot normal vector for plane 2 equals to magnitude of the normal vector in plane 1, magnitude of the normal vector in plane 2 cos theta. As simple as that. So shall say solution. Solution. So we have, now what is your N1? Your N1 will be which one? Tell us there. So your N1 and also maybe your N2. By the way, your N1 is from here, coefficients of x, y, z. N1, coefficient of x here is 2, -1, 1. Coefficient of this will be 3, okay, 2, and then 2, like that. So what do we need? Comma, comma. Now let me just get magnitude of N1 at once. Magnitude of N1 at once will be square root a 2 squared plus -1 squared plus 1 squared. What will be that answer? A root of, shall have that answer. Here also, magnitude of N2 will be equal to a square root of 3 squared plus 2 squared plus 2 squared. That also will be a square root of certain value there. So let's square. This is 2 plus 1 plus 1. This will be 6. 2 squared is 4 plus 1 will be 2, then 6. 3 squared is 9 plus 4, that's 13. This one will give us a 17. If I'm not mistaken. Is that so? Yep, 17. Now you come and say from angle between a plane will be N1 dot N2 is equal to a square root, rather a magnitude of N1, magnitude of N2, a cos of theta. Most students always make a mistake of changing that into sin theta. Please, whenever you're getting the angle between two similar things, we use cos theta. So for example, angle between a line, angle between lines, line and a line, cos theta. Angle between a plane and a plane, cos theta. Most students always tend to change that. Okay. Okay, now we proceed. Now we put N1 here. N1 is 2, -1, 1. Dot N2 is 3, 2, 2 is equal to magnitude of N1 is root 6 times a root of 7, is it 17, a cos of theta. Please, here we are dotting, not crossing. Be careful. 2 times 3 is a 6 plus, rather minus 2 plus 2 is equal to a square root of 6 times 17, a cos of theta. So divide by a square root of 6 times 17 divided by the square root of 6 times 17. You now harmonize. Cos theta will be equal to what? Up here I'll have 6 over a square root. Okay, I'll be having 6 over a square root of 6 times 17. So theta will be equal to a cos inverse of that guy, 6 over a square root of 6 times 17. So theta will be equal to, you get that one decimal place. So you press the inverse of that. Then what are we going to have in the long run? What are we going to have in the long run? What are we going to have in the long run? After that, shall I have 53.6 degrees. 53.6 degrees. 53.6 degrees. Like we are, and that's the angle between those two planes. Another part, we have angle between a plane and a line. Now this is where we use sin theta. Angle between a plane and a line. When they are different, plane line, they are different, then use sin theta. Okay. The angle between a line R is equal to a lambda, a vector plus lambda mu, and the plane any dot R is equal to D. Now this one is the same as our Noah equal to Noah. The same, though I've written in another version. Is given by any dot. Now in a line, in the plane we pick the normal vector, and in the line we pick the parallel vector, the U, only that. And the parallel vector, I said denominator. You can go in the playlist and watch all the videos so that you really understand the science here. Okay. So here we need the normal vector N Normal vector comes from where? Normal vector comes from here. It is a 1, -2, -3. Okay? Then u. We also need u. U is the parallel vector of the line. And here we pick the denominator as 2, 2, and 3. Like that. But then I must get the magnitudes from here. So, comma, magnitude of this. So this will be 1 squared plus -2 squared plus -3 but squared. Okay, which answer shall we have here? 3 is 9, 13 shall have there 14. Comma, magnitude of u. U is equal to, you can call it mu or u, no problem. Mu is equal to a 2 squared plus a 2 squared again plus a 3 squared. So what are we going to have in the end? 2 squared plus 2 squared is 4 squared. That's now 8. This also will be 17. All right, good. So here we can now say that n dot u is equal to magnitude of n times u, a sine of theta. Please here use sine. So you can bring n dot u. N is 1, -2, -3 dot a u is a 2, 2, 3. All right, is equal to, now the n is square root of 14 times the u is square root of 17, a cos, rather, a sine theta. Harmonize very fast. 1 times 2 is 2 plus -4 plus -9 is equal to square root of 14. So it will be a square root of 14 times 17, a sine of theta. Let us now harmonize. So this plus this, this plus this. Okay, so when you simplify here, you see that your sine theta after dividing, sine theta is equal to, simplify here, 2 minus this -2. Okay, this -13 plus 2 will be -11 over a root of 14 times 17. Like that. Let's have more space such that we can, okay, get that done. All right, so when the negative comes in, you ignore the negative. You ignore the negative. Always, when negative comes in, you ignore the negative. Now this will be the continuation here. I'll now have theta is equal to a sine inverse of 11 over, you ignore the negative please, square root of 14 times 17. The angles here must be acute, so ignore the negative. So theta will be equal to, let's press the sine inverse of that. Sine inverse of that shall have a 45.5 degrees. Please make sure your calc is in degrees, not radians. As simple as that. Let us proceed. Let us proceed with more work. All right, so we are in for the mighty vectors, and these are the last lessons. So we are now looking at intersection between two planes. Put a stone this. This is the most technical part of vectors, and it challenges most of the people, but I guess it will be very easy. All right, good. Now they're saying two planes intersect through a line. Yes. The point of intersection of two planes gives us a line. Like say for example, I will use this book. Are you seeing it? This one here is a plane. This one is a plane. But their point of intersection, where they meet here, are you seeing this is something like a line? Their point of intersection is like a line. A plane. This point of intersection is a line. So whenever they find the point of intersection of a plane, then just know you will obtain like an equation of a line. So you shall say solution. So what we shall need here is, all right, solution we shall need here is, in simple terms, all right, so normal vector, n1 will be what? And also n2 will be what? Let's start with that. So n1 is 3, -5, and 1. n2 is 2, -3, and 1. That is it. Now, what you must know, recall, these are normal vectors. Now we shall say that to get a parallel vector, parallel vector also is equal to cross two normal vectors. Cross two normal vectors. Allow me write like that. It is a vice versa. To get a normal vector, cross two parallel vectors. To get parallel vectors, cross two normal vectors. It is a vice versa. So now I need, now remember, because, why am I doing like that? It is because from R is equal to A plus lambda mu, whereby this mu here is a parallel vector. So we have to cross to obtain that parallel vector. Okay? So why I'm going to cross is to obtain this u, the mu, the parallel vector. And how can I get that? Crossing the two normals. So when you have two planes, get their normals, cross them. Their answer will give you the parallel vector. So u will be equal to n1 cross n2. So this will now be, in simple terms, 3, negative 5, 1, then cross, okay, here we shall have a 2, negative 3, 1, like that. So what will be now our u? I told you here, I'll be going direct. What will now be our u? By covering, so that's negative 5 plus 3, it will be negative 2. Cover up this, there's a definite negative there, it will be minus 2, 1 will be negative 1. Cover up here. Please, if you don't know how to cross, go in lesson 2 and watch it very well. So here we have, all right, shall have negative 9 plus 10 will give you a positive 1. So we have our mu, which is there. So we have already gotten this. Now who is missing? The point on a line, the point on a line, the A point on a line. Point on a line. And now how do you get point on a line? So point on a line is got from point on a line. Point on a line. You have already got the parallel vector. The point on a line is not remaining. So point on a line, you will say fix. You fix anything. You say fix x and eliminate. Fix x and eliminate y. So let us fix x and eliminate y in this equation here. So you have 3x minus 5y plus z is equal to 8. The other one is a 2x minus 3y plus z is equal to 3. So we have said fix x and eliminate y. So we are aiming at eliminating y, and eliminate y here we shall need here, I think, a 3. Then you shall need there a 5. What I mean by fixing is you only leave x alone, then you eliminate the y. You have to eliminate, we have x, y, z, but you are not tampering with x. We eliminate y. Our aim is to eliminate y there. So I get 9x minus 15y plus 3z is equal to a 24. A 24, here we shall now have a 10x, right, minus 15y plus 5z is equal to 9. All right, now how shall we eliminate this one? By subtracting. Here we shall now have x, 15 minus 15, negative 15 minus 15 will be a 0. I'll not write it. 3z minus 5z will be negative 2z is equal to 24 minus 9. 24 minus 9, that will be 15. 24 minus 9, that will be 15. And this one here is equation star. I know I have called it equation star. We now need to proceed. Is it clear there? Right, good. Now, let us continue. Now still I will say fix x, fix x, fix x and eliminate z. You keep fixing that very value. So fix x and eliminate z in that very equation. So I will say 3x minus 5y plus z is equal to 8. Okay, the fixing can be done on any, but we have chosen x. 3y plus z is equal to 3. Now, if you fix x and eliminate z, see that we are lucky that this one is z, z. So what you're going to do, you are just going to subtract direct. Subtract, we shall have x negative 5y minus 3 be minus 2y. Okay, minus 2y minus 2y equals to z minus z is 0. I will not write it. 8 minus 3 will give us a 5. This is the equation double star. That is our equation double star. Now, this equation is double star will give us a point on a line. So now we'll say from double star, okay, you say let y equal to 1. You just say let y is equal to 1. This the procedures or the steps we use in this method. You just say let y equal to 1. You are fixing y also to be 1. Since you have been fixing x, you also let y is equal to 1 or any other data. Then let y equal to 1, I will substitute here. So this will be x minus 2 into 1 is equal to 5. What will be the value of x here? The value of x here will be, okay, maybe. So x is equal to a 5 plus 2. So the value of x here will be what? 7. And once you have x as 7, bring back to this. Now we have the value of y. If you have x as 7, y is 1. You now from equation double star. So from equation single star, this one, which is x minus 2z is equal to 15. I have the value of x as 7 minus 2z is equal to 15. Solve and simplify here. Shall have negative 2z is equal to a 15 minus 7. Okay, negative 2z will be equal to 15 minus 7 will give you 8. Divide by negative 2, divide by negative 2. So what will be a value of z? The value of z will be negative 4. Now I think that you have the values of x, y, z. So find that the coordinates in terms of x, y, z, the x, y, z, the coordinates you have them as the value of x is 7, the value of y is 1, the value of z is negative 4. Now this one is a points on a line. Therefore you come and say lambda, rather the line will be equal to plus lambda that. But the mu, we have it as that, negative 2. It is here after crossing negative 1, 1. Then the point on a line is this, the 7, the 1, and the negative 4. They wanted what? They wanted a Cartesian equation. A Cartesian equation which implies that we have to slowly proceed a little bit with that. So Cartesian equation, you know how to convert to Cartesian equation? Yes. Where we have the x, y, and the z, they are like that. So now from there, a Cartesian equation will be got from there, Cartesian equation will be the r changes into x, y, z, and is equal to, all right, 7, 1, negative 4, plus lambda, negative 2, negative 1, 1. Now I know some teachers use different methods here. It is okay. You still try with the method, you will see that the answers will be the same. I consider this to be a bit cheap. So now this one will be, all right, so this will be that equals to that equals to that. Denominators are these, negative 2, negative 1, and 1. Like that. About mistaken. Now it will be now have x, you have y, you have z. For x, this comes this side, so x minus 7. This comes this side, y minus 1. This comes this side is z plus 4. And that is our Cartesian inequation of a line. That line is now the point of intersection of a plane. Okay, so let's conclude with lesson 10. Let's conclude with lesson 10. You're saying shortest stop perpendicular. They can say shortest distance or perpendicular distance of a plane from a point. So these are plane and perpendicular means an angle of 90. A point is away. Now the point is x1, y1, z1. Now here, the simple trick is you get the point and substitute it into equation of a plane. I'm not mistaken. That's what we do. So distance is equal to, now I think that from here, only that what they've altered here is they put here minus. The next is where there was x, they put there x1. Where there was, sorry, this is qy. Where there is y, they put there y1, which y1 is for the point A. While there is z, they put there z1. Then minus d, d is a constant of that plane. So now over, now here, p squared plus q squared plus r squared. They square this, they square that, they square that. Okay. An example, find the shortest distance between a plane 2x plus 4y minus 2z is equal to 3. 2x minus 4y plus 2z is equal to 3. That's what we want to find. Now in our solution we shall say, in our solution we shall say, All right, so solution. So now we shall say that D, the distance D to magnitude of P, x1 plus Q. Okay, the distance is equal to Px1 Qy1 plus R Z1 minus D over that's what you're having. And now what does it mean? What does it mean? It means that we shall now say, now what is our P? So just know that your P, Q, and R, what are they? Your P, Q, and R from the plane here is 2, 4, -2. And what is your D? Your D is equal to 3. Please, regardless of whether it's a negative or positive, take it as a positive. Is 3. And the point, we have a point on that plane is 2, 1, -2. So this is the x1, y1, z1. Now what we're going to do, we're just going to substitute. So distance D is equal to magnitude. What is our P? Is 2 into x1 is 2 plus Q is 4 into y1 1 plus R is -2 into Z1 is -2. Then from there minus, what is our D? Our D is 3. Okay, over a square root of P squared. Our P is 2 squared plus 4 squared. Okay, plus -2 but squared. Your answer must be there in all right, units. And that will finally be a 1.8371 units. To be a 1.8713 units. Please also press in your calculator and confirm. We may end up making a mistake anywhere. Okay, yeah, and I think that is all. That is all. Now, the other part of vectors we left out was finding the orthocenter, finding a circumcenter, and to show that they are orthogonal. Those are the parts we left out, and they will be coming up also in the playlist. The parts I handled first are the ones which are most common in most of the question papers. Sensitive areas. The others of orthogonal and circumcenter are not so common, but we shall also step into them. For now, we can be learning that. Thank you. Don't forget to subscribe. The subscription is a token of appreciation. But indeed, we are a bit trying.